Hello, my name is Klajdi Bodurri, and this summer I got selected to do a project for the summer of HPC. The project title is Dynamic Management of Resources Simulator, and I will try to explain it throughout this video. First, let me explain some terminologies that I'm gonna use later on. As we know, in HPC facilities, tons of applications run concurrently and compete for the same resources. Application request for resources from the resource manager in order to run. The resource manager gives the resources to the application based on a policy. From this, we can understand that the resource manager plays a vital role in global throughput of the system and in the resource utilization. One more thing that I should explain is that some applications have some characteristics. One of these is malleability. Malleability is the ability to dynamically change the number of computational entities in an application. In other words, an application can change the number of resources while it is running on the fly. So, what if a research manager exploits also malleability of the applications by using a specific policy for malleability? This is exactly what is the project about, giving a workload, malleable and non-malleable applications as input to the simulator, and by trying different configuration policies of the research manager, we can determine the best configuration without even running the workload in an HPC facility. I know that I said a lot of things, so let me show two basic examples of how the research manager should behaves with and without malleability and how the throughput is affected. In this example, the research manager has 16 available resources and an application comes and asks for 16 resources. So the research manager sees that it can fulfill this request and gives 16 resources to the application. So the application starts running. After some point, another application comes and asks for the same amount of resources as the first application. But the resource manager cannot fulfill this request yet because there are no available resources. So the second application has to wait for the first one to release the resources. The resource manager puts the second application in the waiting queue. When the application 1 decides to release the resources, informs the resource manager, and now the resource manager can give the resources to application 2. So application 2 can run. In this example, we saw that we had throughput 1. Let me now show another example with the same applications, but now they are malleable, and the resource manager can exploit that by running a more complex policy that supports malleability. Now the application says to the resource manager the minimum and the maximum number of resources that it might need. Since now the application is malleable, it can run with any number of resources between the minimum and the maximum. So application 1 asks from 1 to 16 resources, and the resource manager can see that it has 16 available resources and gives them all to the application 1. The application 1 starts running, and at some point another application comes and asks also from 1 to 16 resources. But now the difference is that the resource manager can exploit the malleability of the applications, so it decides to change the number of resources from the first application from 16 resources to 8. And gives the other 8 resources to the second application. So in the end, both applications are running with 8 resources. We saw that we increased the throughput because of the malleability, but of course there is a drawback. The drawback here is that, okay, the applications are running concurrently, but they are running slower since they are using less resources instead of 16 that we had in the first example. Now, let me show you a demonstration of the simulator. So right now the simulator supports two policies for malleability, and we want to see the difference between them. So let's create a workload of 100 applications. Each application has a minimum number of resources 1 and maximum number of resources 8. Also, the application has a preferred number of resources. We use this number in one of the two policies. This number can be any number between the minimum and the maximum. One more thing to say is that the available resources are 16. So let's run this workload with the first policy. It's called always expand, and it's a policy that my supervisor has written in his paper. Let's see the results. So now it is running. It takes some time, of course. So the final result is here, sorry. So here we have that the running time of the workload was 4,994 seconds. The maximum throughput of the workload was 4, and the average throughput was 3. Let's compare it with the second policy that our simulator supports. The second policy is called homogeneous, and it shares the resources to the applications homogeneously. Like if we have 16 resources and we have 8 applications, then each of application will have 2 resources. So let's see. Okay, let's copy this here. Okay, so we run the same workload but with different policy, and we can see the results of course are different. Here the execution time of the workload was 4,356 seconds, and the maximum throughput was 16 and the average 15. We can see clearly which policy is better for this workload. In conclusion, if someone wanted to compare these two policies that exploit malleability and see which one is better for the same workload by running the workload directly on the system instead of running on the simulator, it would have taken around 2.5 hours to 3 based on the execution times that we had from the simulator. But we get the same resources. We can get the same idea of how these policies behave by running them on the simulator and wait only 30 seconds instead of 3 hours. This is what my project was about: implementation of a simulator that simulates a resource manager which can support different policies. Thank you very much.